Alright, so in this clip, we're going to talk about something which is very interesting. Alright, so here I would like to begin with the fluid and I would like to consider the polygon piece of the object for the fluid emitter. Alright, so let's just quickly begin with that. We have the fluids over here and let's go into the 3D container by default, and we don't have any emitter. So very quickly I would like to do the blocking of my scenes. So we have, let's say, 15 centimeters inside the x-axis and let's say the 20 to the y, and let's leave that to be 10 or maybe 8. Okay, not a problem. So I would like to add a polygon object inside our scene. So let's say we go with a torus, and I would like to tweak that thing a little bit. First of all, the section radius is way too much high, so I would like to reduce it to 0.3 or 0.35, and I would like to give some subdivision axis. Alright, so that will gonna make it a little bit more smooth. And I also like to get rid of the section radius to, let's say, 0.25. That's great. Okay, so first of all, I like to name that thing, let's say the fluid underscore emitter. That's good. And let's just get rid of the grids. I would like to keep the object over here. So freeze transformation, everything is done. So I just want this object again to be at the center. So the how do we going to assign this object so that it can become the emitter for the fluids? So first we need to select the object, then the fluids. We can go inside the fluids and we have added contents. You can see we have the emit from the object. Now in this case we need to use the emit from the object instead of the emitter. Alright, because if we go over here, you won't going to find that options where the surface is written. Alright, so we need to go over here, fluids, and we have the add edit contents, and we need to click the emit from the object. So surface will going to be there for you. Applying close. Alright, so this object has now become the emitter for the fluids. Alright, so you can see that the fluid emitter is over here, no problem. So now getting back to the fluids, first of all I would like to increase the base resolution, so let's say over 80. Okay, and let's just first get rid of the boundary draw to the bounding box, not a problem. Okay, so if you like to play the fluids, you can see that something which is pretty normal is happening. The fluids are been getting emitted from the polygon piece of the object, and there is nothing fancy going around. So as long as we run the timeline, the fluids should keep on getting emitted from the piece of this particular object. Let's dive into the interesting parameters of this emitter. And again, first of all, I'd like to switch off the heat and the fuel so that it will avoid some confusions. And now I would also like to give some turbulence, let's say 10, and also bring it to the 1. So now if we like to play the timeline, you could see that there's a nice variation to the fluids coming from the other side. So here you can see that the pattern is being getting changed. So if we would like to change the value of the turbulence speed, you already know that the frequency of the disturbance will going to occur a little bit more faster as compared to the lower values. Okay, now it's time to move inside the speed method, where I would like to initially keep it as a replace. And there's something interesting, no doubt, inherent velocity we're going to cover in this clip, don't worry. Here we have something called as a normal speed. So first of all the question comes, what is a normal? And then the speed, only then it will become normal to us. The normal here is representing the normals of the polygon piece of the geometry, which is a reference vector perpendicular to the center of the face. Let's just do one thing, we'll make it visualize. So how do we going to do that? There are several ways to do. I would like to go with a very simple one. So select the object, under the shape node we have the mesh component display, and over down we have the display normal. So the moment you click it, you're going to see a reference vector, a line which is perpendicular to the center of the polygons. Alright, so you can see that the angle of the normals are also being getting changed because of the change inside the direction of the face. Alright, so I just would like to switch them off, and you can also increase them based upon your convenience level. So just switch them off. So this is the the normal speed, or you can say the normal speed, yeah. And how does it going to affect? Well, we need to increase that thing, let's say 10, and notice that once I start playing the timeline, some of the fluids will start flowing in this directions, or at least I should say in this way. All right, pretty bad way to display, sorry. So we just play the timeline. Now you can see that based upon the direction of the normals, fluids are being getting emitted from the piece of the polygon based upon the angle of the normals. All right, what if we like to do the add method? Then it simply means that the fluid will obviously going to get emitted, but again the fluid will going to join to their previous velocities. So add simply means that it will going to add to the existing velocities. All right, and replace, by the name it suggests, it will going to completely replace out the values. So if you replace them, if you increase them, now notice that I think so it will be very difficult for the fluids to get back to their previous values. Some of the fluids are trying to be getting over here, but don't forget that the direction of the normals was also towards to the upside also. All right, so this is a very fascinating thing inside the emission speed attribute what we have. All right, so I like to put that thing to 0. Now the main game is going to be get started. All right, now I just want you to pay a lot of attention, because this is extremely important section of the fluids, and I have seen people got failed in the test, in the interviews. I mean, this is such an important attribute that I can't stress enough. So what exactly is this? Just take a look at by your own. All right, what I want is that I want now to animate the emitters. All right, now that's something which is pretty much new. We haven't did that before. So first of all, I would like to get it back to its previous positions. And the thing is that once I start doing the animation, I definitely have to scrub the timeline. So you can see that unnecessary the fluids are being getting emitted from the container, so which is I really don't want. So the simple way to address this problem is that you can go inside the shape node, and there's something called as a disable evaluation. You just click it. Now the moment you play the timeline, you can notice that there is no movement inside the fluids. The another way to do is that you could go inside the modify, and there's something called as the nodes, evaluate nodes. Kindly switch off the fluids. All right, so there are two ways. So now I would just quickly like to animate that stuff. So at frame, and yeah, I also like to reduce the time frame, or you can say the the frame ranges. So I would like to key, let's say key selected, at frame, let's say 15. I would like to take that object over here to somewhere around in the middle of the fluid containers, and I would like to key them up. So that means we do have something like this. And again at frame 30, I would like to, let's say, copy this one and copy this one and get it back over here. And the only thing which I want is that I can manage the translate x-axis. So we put the key over here. So the simple animation is some I also have to tell you one thing, that before we play the timeline, as you can see that there's something nice happening over here, which is surely the way I don't want. So I just need to go inside the preferences. All right, and from the max playback speed, I need to change that thing to the real-time 24 fps. So that means my maximum speed cannot be more than 24 frames. That means in 1 second I could able to see or visualize only 24 frames. All right, so when we are dealing with the dynamic stuff, or you can say the simulations, we want the playback speed to be the play every frame. All right, when you do the animations, you always change your preferences from the playback speed from play every frame to the real time 24 FPS. Alright, so I would like to put that thing to the play every frame since we are doing the simulations. Alright, and save that thing. Now if you're gonna play the time, you can see that alright, now max playback speed is 24 FPS. Okay, but as you can see that I cannot able to capture any interest inside the animations of this object, since we also need to follow the principles of the animations. So in that case the gravity is not taking place, or you can say I could take you to the bouncing ball animations a little bit. So go to the graph editors. So focus first on the green, that is the translate C, and here we would like to maintain the graph in somewhat like this way, and let's say scale them a little bit up so that this is the graph that I learned in my school. Alright, and we just need to get rid of this, the middle key, and let's say from the x-axis the path need to be, let's say, linear. We don't want to be slow in and slow out. Let's say this thing to be linear. So now you can see that, yeah, absolutely, now we could able to get some weight inside the animations. All right, pretty good. And I also would like to increase that thing to the 45 so that I should also want to see how this object being getting stayed over here. So pretty much is okay, not a problem. And let's just do one more thing. We can also rotate this object. So let us say where the rotation is taking from, it is happening in the z-axis. So we like to maintain a Q over here. So at frame 30 we would like to give at least 2 times the overall rotation. So 720 is the key, and let's say key selected. So now you can see that it's pretty much good. So it just move up, take some rotations. There's a kind of a twisted motion inside this piece of the object, so it settled down fine. So the main story is yet to begin. We would like to again switch off the disable evaluations, and I also would like to reset everything. Let's say turbulence, everything gone away. Now you're going to tell me what exactly is happening wrong. So can you see that what exactly is happening? The bad thing is that first of all there's a kind of a stamp spacing inside the fluids. Stamp spacing means that you have the missing fluids, which simply means that some of the frames has been skipped, or due to the fast motion of your object, fluid fails to evaluate those frames. Well, that could also be addressed with the help of the shape node of the fluids with respect to the dynamic simulations, utilization of the substeps, and the solver qualities. But I don't want to get inside to this because our main focus is only on the fluid emitters. So let's do one thing. Let's focus and concentrate only upon the fluid emitter and try to get rid of this thing. So the very first thing is, under the fluid emitter we need to utilize something called as a motion streak. This wonderful option will try to minimize the gap of the fluids, alright? But you also need to be careful with one attribute. Let's first play the timeline. Now can you see that? Well, everything seems to be good, but the problem is that we have lost the motion of the fluids with respect to the object. That means the emission of the fluids was taking place from the torus, but here it seems to be like that a sphere has jumped from this place to this place. So this is absolutely wrong. I cannot see the gap inside the fluids. Well, the reason is why, because once you switch on the motion streak, there's something called inside the basic emitter attributes, which is the max distance. Now pay attention over here. What this attribute simply going to mean is that from the most outermost point of the polygon piece of the mesh, let us say I'm considering this one. Okay, So from this point to at least 1 centimeter, the fluid will going to get emitted from all the points. So you got it? So that means I would like to fix, okay, select that up. So we would like to reduce the value of the max distance. Okay, here it is 1, so I would like to give it to the point 2. Okay, now let's take a look at that, what exactly is happening. So we did that thing, but the problem is that most of the fluid has already been lost in the way. So how are we going to fix it? The best way is that if you have reduced the max distance to 0.2, you should increase the rate percentage. So at 100 to at 1000. Now take a look at that again. I think so we are getting a little convincing results. Not like that much convincing, but still better as compared to the previous one. Alright. I can also do one more thing, that I can increase either the density, or I can also increase the rate percentage. Alright. That will going to give me some more fluids inside over here. But I prefer to go with the density. Alright. Now the main thing will going to get start. And the main thing is that now we would like to utilize the inherent velocity feature of the fluids. Just take a fact, just take a note that once we are playing the fluid, you can see that the fluids are just being, getting pushed to the upward side. This is just because of the buoyancy inside the density. And we don't have anything related to the motion of the emitters. Like it's been getting spin, it's moving from this point to this point, so there is no reflection of the movement of the emitter inside the fluids. So this particular attribute, inherent velocity, will going to address this. So that means the fluid will going to be get inherited by the motion, or you can say the transformations of this torus object. So first I would like to begin with small values. Let's say we like to go with the 1. Okay, and if I'm gonna play that, you can say something magical is happening, and I'm very happy to see that. So I hope so I made my point pretty much clear to all of you guys. Now you can see that this is being one of the most difficult and problematic thing inside the fluid dynamics, to get rid of this, this stamp spacing, or you can say the missing fluids. And now I hope so you have learned the art of getting rid of the kind of the bad stamp spacing effect that was happening inside our reactions. One more thing we could do to fix that thing, and that is, if you go to the preferences, you have the provisions to play back, or I can do also one thing, that once my animations are done, I can bring it back to the free, and I can reduce the playback from 1 to the 0.5. So what this will going to do, that the fluid will take 2 frames to sample the motions. So now you can see that there's a lot of smoothness happening over here. Earlier, if I take it back to the, let us say if I take back to the 2 frames, which is pretty much high, now you can see that there is a kind of a problem over here. Well, the problem is that there's a kind of a jitter, and this jitter indicates the instability inside the fluids. That means the fluids are being getting unstable totally. So we could get rid of that thing also, if we're going to utilize the under the dynamic simulation under the fluid shape node, by increasing the sub steps to 2. All right, we could also get rid of that. But since now we are focusing totally upon the fluid emitter, I just want things to be get solved through this way only. Although practically it's not possible that we're going to take playback to the 2, but this could be possible, that our time frame from 1 to 30 may could get reduced to 1 to 10. So in that case, you may could calculate that the playback speed is 1, but the frame has been reduced. So obviously the speed will going to be increased with respect to the existing time. So you have to do in that way. And what if we take the speed to the 0.25, which is 1/4 of the one value? Now you can notice that we have amazingly smooth and soft motion of the fluids. So if in case you want to, simulate the fluids in slow motions or in slow FPS, you could easily able to do this kind of an effect. All right. I'm pretty much happy to share this knowledge or this information with you because this is a very annoying and disturbing feature of the fluids. If you really don't know, it would be very, very hard to, you know, create a good effect. And in most of the cases, in feature films, advertisements, we do have, encountered such kind of problems. So the only way to fix that up is to utilize the, let me first stop this, to utilize the motion streak, take care of the max distance, and also take care about the rate percentage. All right. So I hope so this makes some sense to you. So see you in the next clip.